Okay, we're going to look at 7.3 homework. It is asking us to calculate the sample error or sampling error, and I've gone to you an example to kind of show you. X bar, anytime you see X bar, that is your sample mean, and this is known as mu, your population mean. So the amount of error in your sample depends on how big your sample actually is. What we like to think of is the bigger the sample, the more accurate the mean would be as compared to the population. If you have a small sample, your error, your sampling error, is more than likely going to be larger because it's not as representative of the population if it's bigger. So the more information you have, the more accurate your statistic will be. So what I want to show you is here you can find the mean. You know to find the mean, you add them up, find your average, add them up and divide by the number that you have. But if you want a quick way to do it, this one really wouldn't take long to do by hand, but you can open in StatCrunch, go to Stat, Summary Statistics, click on Columns, and we want to find the mean of this column, which is variable 1, and hit compute. Now it's going to give you a bunch of information, but all we need is the 127.125. That is what we call our sample mean. So to get your sampling error, you would take 127.125 and subtract that from 129, and that is how you get this number right here. So that's basically all that you're doing on these types of problems. Okay, so moving on to question number 2. Okay, the first thing it asks you for is to find mu. Okay, and this is our numbers. Okay, so this is going to be our population. This is all the information on the 20 listings. Okay, so you can calculate what we call mu, the population. You could add them up and divide them by 20, but I'm just going to use StatCrunch, and I'm going to crunch this number, and I get 34.5 for the mean, for mu, the population mean. Now, to calculate the sampling error, we're going to use the first 5 numbers. This is our sample, okay? We're going to find our sample mean, and we already know mu, our population mean. So we're going to use the first 5 homes. That's our sample. So we're going to add 1, 2, 3, 4, these 5 numbers up, and we're going to divide it by 5. When you add those numbers up and you divide it by 5, let's see, 25, thought I'd added these up somewhere. I may have added them up in my head. You're going to take this, 25 and 21 is 46, 46 and 1 is 47, 47 and 15 is 62, and then 62 and 33 is 95. So you're going to take 95 and you're going to divide it by 5, and you're going to get 19. So what that tells us is the sample mean is 19. Take the sample mean, subtract the population mean, 19 minus 34.5, and that is how you get the sampling error. You do part C the same way, except this time you're going to have 10 numbers. So you're going to take all these numbers at the top, add them up, divide by 10. That is your sample mean. Subtract your sample mean from your population mean, and you get negative 5.7. Be careful. When I was working the problems, my mistake was not actually the calculation, but remembering to round to the nearest tenths or hundredths. Make sure you read what it's asking you to do, what it's asking you to round to. How does increasing the sample size affect the sampling error? The bigger the sample size is, the smaller the error will be because it will be more representative of the population. So remember, if you want it to be precise, if you want your sample mean to be as close to the population mean as it can possibly be, you need to make it larger. And then I want to say all of these are very similar, but let me go to question 6 because this was one that I could see students struggling with. Okay, so the sampling error. Draw a systematic sample consisting of 2 temperatures and then calculate the sampling error for the sample. So how do we draw or figure out a systematic sample? What you do is you take the size of the population and you divide it by the size of the sample, okay? So our sample that we're picking from is the number 2. The population is in this table right here. We have 28 numbers. So 28 is the population divided by 2 is the sample. So 28 divided by 2 is 14. So our sample is every 14 numbers. So our first number would be 57.7. Then go up 14 more and you would be at 28. So our other number is 45.9. So those are our 2 sample numbers that we will use. So how do you find the mean of the sample? You take your 2 numbers, add them up, 57.7 plus 45.9, and you divide it by 2. Okay, and that is going to be your sample mean. Remember, sampling error is your sample mean minus your population mean. So we need to calculate our population mean. So you open in StatCrunch. You go to Stat, Summary Statistics, and we want to calculate these number means, not this is data number 1, number 2, number, those don't matter. We just want to calculate the population mean of the temperature. So click Compute, and the mean is 50.06. Okay, so how do we find our sampling error? Remember, our sample mean was those 2 numbers, add them, divide by 2. Okay, so whatever you get for that, and I want to say, let's just do that real quick. Our 2 numbers were number 14, which was 57.7, every 14 numbers. So our second number is going to be 45.9. Add those together, divide by 2, and you get 51.8. Subtract that from your population mean, and your sampling error is 1.74. Now, for part B, it's basically the same thing, except this time we're going to have 4 numbers. So we have 28 total numbers. If you divide 28 by 4, every 7th number is going to be one of our values. So 45.5, 57.7, 46.6, and 45.9. So you would add those numbers together and divide by 4. When you divide that by 4, you will take that, whatever that number is, that will be your sample mean, subtract it from 50.06. For C, you're going to do the same thing. 7 is our sample. 28 divided by 7 is 4. So every 4 numbers it's going to be, or we're basically going to have 7 numbers. So every 4 numbers. So that's 1. That's our second number. This is our third number. This is our fourth number, fifth, sixth, seventh. So you would add those numbers up and divide by 7 and get your mean, your sample mean. Take that sample mean and subtract it from your population mean. Remember, sample mean minus population mean. The last part is really the only part that is a little bit confusing. And it's really the wording. Just be careful and make sure you read it carefully. Compare the sampling error reports A, B, and C. Explain the reason for the difference. In general, increasing the sample size makes the sampling error smaller. The sample obtained in part C does not follow this trend. C, it went from 1.74 to 1.14 to negative 5.29. Okay, so we went from 2, 4 to 7. So we're making the sampling, the sample bigger, so the error should be smaller. Okay, well, if you notice, the error gets bigger. Okay, that's not typically normal. The error should get smaller if the sample gets bigger. So in general, it does that, but part C does not follow this trend, and that can happen. And then the last question, what problems might be encountered with the sample obtained in C? Basically, it's saying, if you're looking at temperatures, you're recording these periodically, things can change as far as what time of day you're getting the sample. That can affect how you're picking the temperatures. Certain part of the days is going to be cooler or warmer. The sampling error can be affected by that, by the average temperatures. And that's pretty much chapter or section 7.3.